Hey, Algebra 2A students, how are you doing? I hope you've already watched the first video message that I've sent you that just kind of goes over how we're going to do business over the next few weeks, and let's hope that's all it is. But anyway, let's get started with our first learning activity. And I wanted to show you that I gave you this worksheet in your packets, and we actually started this worksheet together in class on that last Wednesday before spring break. We did part of it in small groups, and then I told you that we would finish it together on your first day back. I don't know if you remember, but what came out in your packets, you only had 2 of the 3 pages, and we had to write down the problems from the 3rd page. Well, I'm assuming that some of you did not bring home all your papers and things, that you left them at school over the break, which I totally get. And so I'm going to post this worksheet on Canvas right with this video so that if you want to print it, you can, and then you can take your notes. Now, I'm going to do this every day. I'll provide skeleton notes that go along with the lesson because that'll make it easier for you to follow. Even if you don't want to print or you don't have the ability to print at home, then get notebook paper out and write down the problems along with me, because writing the problems is going to give you a record of how to do things for when you are trying to do the homework on your own. It'll be easier than going back and forth to the video. And just the process of writing begins that process of learning. That's the big deal, is that I always say there's a direct connection from your hand all the way up your arm to your brain. So that's the way you'll begin learning and taking this information in, okay? So if you need to pause the video so that you can go run and get notebook paper, or so that you can access the document on Canvas, and you want to download and print it, do. Remember, on all of these videos, you can pause them, rewind them, pause the video to write something out if you feel like I'm talking too quickly, or if you need to rewind and hear me say something again, or look at what I've written again. That's there for you. Use those options until we start flowing more smoothly. My videos will probably get better and you'll get more used to this process. And then don't forget, you can email me, or ideally you'll meet me online in my online office hours on my online Zoom classroom. Let's hope that works. And you can actually ask me to work problems with you, okay? So let's get started. Let me, instead of working every single problem, let me remind you that we were talking about there being 3 forms for all quadratic equations that we're going to work with. So one form is standard form, and that's pretty typical that you'll see it, and it's the y equals ax squared plus bx plus c format. So that's what I'm showing right here. Now, every form that we deal with has something that makes it an easy-to-use form. So when we're graphing, standard form makes our y-intercept really easy to see. Okay? The second form that I know that you're going to like is vertex form. Vertex form is my favorite form, especially when I'm having to graph, because the most important part of the graph is the vertex, and vertex form makes the vertex really easy to see. So we'll start out on our next lesson working on finding vertex, because that's like the most important part of the graph. So the last form is factored form. So that might be, for instance, like an example might be if I had y equals 2 times x minus 4 times x plus 7. That would be a factored form. And factored form makes the x-intercepts easy to see. So the most important part of a graph is the vertex, and I would say the next most important parts of the graph are the x-intercepts, and the third most important part of the graph is the y-intercept. So all of these forms have something helpful to offer. Now, we talked about this before you left. If you have a quadratic equation, and we'll say, and I'm just going to write it on this page, if you have a quadratic equation that looks like y equals 2x squared plus 6x minus 4. That's a quadratic equation that you're going to be graphing because you've got y equals. If you have 0 equals 2x squared plus 6x minus 4, then that's a quadratic equation that you're going to solve because it's set equal to 0 instead of being set equal to y. So we're going to be working back and forth between these two ideas. Now notice that both of the forms that I gave you have ax squared plus bx plus c form on the right hand side of the equal sign. So that means both of those equations I gave you are in the standard form. Remember, we're going to work with standard form and vertex form. Those will be our most frequent. And then factored form off and on, because I want you to just be familiar with that. Now, it doesn't matter whether we're working in standard form, vertex form, or factored form. When I have a quadratic equation with y equals, and I'm graphing, the graph will turn out to be a parabola. And you'll see 8 examples of parabolas. So I would say that this parabola, your third example, is your most basic parabola. So I see that its vertex is at 0, 0 right here. It opens upward and it's a nice, neat U shape. Well, then you can see that I can take the parabola and I can make the parabolas fatter. Like this is a fatter than normal parabola. This is a fatter than normal parabola. I can also take parabolas and make them skinnier. So I've got a skinnier than normal parabola here and here. And you'll also notice that I can take the parabolas and in addition to make them skinnier or fatter, I can turn them upside down. Of course, you'll see that the 4 parabolas on the bottom row are upside down. They open down, while the 4 parabolas on the top row are right side up. They open up. So we'll talk about all that stuff getting into tomorrow's lesson. But I can also take the parabolas and I can move them around the coordinate plane so that their vertex is not at 0, 0. So again, this is my most normal parabola because it starts out with its vertex on the origin. I can take a normal parabola and I can move it around and I can make it skinnier, fat, and I can make it turn upside down. And that's what we're going to explore over this next chapter. All right, so what we're going to look at today is just a general review of what we were doing before spring break and how that connects to a graph, which we did talk about this before you left. That I want to look at the X-Intercepts. Now it says Y-intercepts, and I'll get back to this slide and add Y-intercept information on in a later lesson. But the X-intercepts are the points where the graph crosses over the X-axis. So if you have 2 real solutions, there goes my computer where my board's not writing where I want it to do. If you have 2 real and different solutions, the graph will cross the x-axis. The parabola crosses the x-axis at 2 different points on the x-axis. So I'll say the graph crosses twice. If you have 1 real solution that's repeated, and we talked about that being a double root, then your parabola is only going to kiss the x-axis once. So it might kiss the x-axis sitting on the x-axis, or it might come up and kiss the x-axis hanging below the x-axis. But I'll say this parabola crosses the x-axis twice, and this parabola kisses the x-axis once. So not only am I going to talk about once and twice, I'm going to be talking about crossing versus kissing so that we have more descriptive verbs there. And so last but not least, if you have a quadratic equation and you solve it and you get non-real or imaginary answers, it's telling you that the parabola never touches or crosses the x-axis. So there are no x-intercepts on the graph. So the parabola never touches the x-axis. So I'm saying the parabola never crosses the x-axis, the parabola never kisses the x-axis. There's no touch at all. All right, so let me mention something else we talked about before the break, okay? We want to find the x-intercepts. The x-intercepts, which I've got in this pink box there, that is the most formal name for the points where the parabola crosses or kisses the x-axis. But you're going to hear me use the term roots. These are all other names, vocabulary terms you'll hear. I tend to use the word roots quite a bit. On your graphing calculator, you'll see zeros used as names that go with x-intercepts and roots. And we can just say the solutions of the equation, because when we solve a quadratic equation, what we're actually finding graphically is the x-intercepts, roots, or zeros. So sometimes people will also say solutions for this too. It's less common, but it does mean the same thing. So, big ideas and what we're going to do in this lesson. There are three forms of quadratic equations: standard form, vertex form, factored form. That's our first big idea. Solving quadratic equations that are set equal to 0 is the same as finding where a graph crosses the x-axis. So again, we solve a quadratic equation if you have the equation equal to 0. And then you get x equals this answer, x equals that answer. All right? You graph a quadratic equation if you have the equation set equal to y. And normally you'll see it as y equals the equation. And it doesn't matter if the equation is in vertex form, standard form, or factored form. So when we find that x equals this or x equals that by solving, what we're finding is the points where the parabola crosses the x-axis or kisses the x-axis when it comes to graphing. All right, and remember, the points where the graph crosses or kisses the x-axis are officially called x-intercepts. This is the official title. You'll hear me say roots quite a bit. Zeros are also a common way that people will refer to x-intercepts. And it all means the same thing. Okay, when you solve a quadratic equation, you can tell without having the graph whether the graph crosses the x-axis twice, kisses the x-axis once, or never touches the x-axis. And that's the goal of this bridge lesson that connects us from what we did before spring break to what we did after spring break. Now, let's, in this first video clip, let's review what we did before spring break. So the first example that's on the worksheet is this y equals 2 times x minus 3 squared plus 5. Now, I'm pointing out to you that this is in the vertex form because I'm telling you the a is your 2 in this case. The x minus h is x minus 3, and the plus k is plus 5. Okay? So that's our vertex form. Now, if you'll look, so I've already said this is vertex form. If you'll look at the worksheet that I gave you, or I can take you back for just a minute. I'm not sure I put it on here. I will double check. I'm not sure I did. Okay, so let me move forward and I will write it in. On the worksheet, if you look at it, and it does say it here, if you look at the worksheet, it reminds you that if you want to solve in vertex form, and I know it's a solve problem now because it's equal to 0, that always the easiest way to do that is by taking square roots. So when I set the equation equal to 0, I subtract 5 to the right-hand side. I divide by the 2. This 2 needs to be divided to the right-hand side. When I get to this magic form where the squared part is by itself on the left, that tells me I can take square roots of both sides. Taking the square root of the left-hand side gives me x minus 3. When I take the square root of the right-hand side, remember I introduced the plus or minus symbol, and taking the square root of the fraction is the same thing as taking the square root of the top of the fraction over the bottom of the fraction, okay? The reason I don't have the square root of negative 5 written out is because I automatically know that that's the square root of 5 and it turns out imaginary. So I went ahead and took care of that in this next step so I can condense some steps. I've got 2 more things I need to do. This negative 3 needs to be added to where it's positive 3 and put that 3 right after the equal sign. The plus or minus is still just in the middle there. And remember, on the radical part, you have to multiply by square root 2 over square root 2. So root 5 times root 2 is square root 10. The I comes to the outside on the right. Square root 2 times square root 2 on the bottom is plain 2. Okay? So we did that one before the break. Now, the next equation that's in the list is this y equals negative 1/2 x squared plus x plus 15 halves. I'm pointing out to you its standard form because I'm saying that my a is negative 1/2, my b is 1, and my c is 15 over 2, so that I've got standard form. Now, when you're solving right here, a standard form equation equal to 0, then you try factoring first. All right, if we realize pretty quickly that factoring won't work or it's just too messy to keep plugging away at factoring, then you're going to switch to complete the square quadratic formula. And we will review as we go why complete the square would be easier and faster on some problems, but then why on many, many others quadratic formula is actually better. So I want to remind you that once you set the equation equal to 0, it expands your options. So once I've got it set equal to 0, I can clear the fractions. I can't do that when it's equal to y because then you change the problem I gave you. But once you set it equal to 0 when you're in the solving phase, you're allowed to clear fractions, so by all means do. Notice that we multiplied by negative 2 to clear our fractions, and we come up with this much simpler equation. So remember, if I'm using AC method, then my AC is negative 15. And I know that the other day we could have said, well, that's like negative 1 times positive 15, or positive 1 times negative 15, or positive 5 times negative 3. But you all really quickly said that if I pick negative 5 times positive 3, I get negative 15. And then negative 5 plus 3 gives me the negative 2. Okay? So we factored more quickly by saying that's x minus 5 and x plus 3. So that minus 5 is right here. And the plus 3 is right here in the problem. And then if I have it in factored form, seeing x equals 5 and x equals negative 3 is super duper quick. So, guys, I want to remind you, since I got 2 real and different solutions, I can translate that to mean that my graph will cross the x-axis twice. And that's all I want you to connect for right now, is that we're getting information about what to expect when we do begin full-out graphing on the next lesson. So here's a similar problem. The third problem on your worksheet is y equals 3/4 x squared minus 21/4 x plus 151/4. Okay, guys, this is also standard form. I've got A is 3/4, B is negative 21/4, and C is positive 151/4. Those are not pretty numbers to have to work with. But never fear, when we go to solving and we set it equal to 0, then I get to clear fractions. So I immediately multiply through by 4, and I get this equation, the 3x squared equation, which looks better. Now, it could be that 3x squared minus 21x plus 151 equals 0 factors. But when I'm looking at it, the 3 and the 151 are really large. If I tried to do AC method, my AC would be 3 times 151. What is that, 453? And then my B value would be negative 21. Well, with 453 being such a large AC, I could work and work and work and work and work and try to get the thing to factor. And then if it didn't factor, then I would feel like I had wasted my time. So my general rule of thumb is if it's a super large AC, then you probably want to switch gears and move on to complete the square or quadratic formula. Now let's right quick talk about why did we go with quadratic formula, not complete the square. Okay, so I'm going to write not complete the square right here and give my reason why. So if you complete the square, remember you leave the x's on the left and move the plane number to the right. Then I can't complete the square as long as that 3 is there. So I'm going to factor that 3 out and have x squared minus 7x plus a space equals negative 151 plus a space. Here's the problem. If I'm going to complete the square, if this middle term is either odd or fractional, then completing the square is super messy. So that's why I'm choosing to not complete the square and just do quadratic formula. So I'm not going to continue on with complete the square because it's just too messy in this case. So I, of course, have x equals negative b, which is 21, plus or minus the square root of b squared. Remember, we go straight to b squared. That number's always positive, so negative 21 times negative 21 is b squared. That's 441. Minus 4a, a is 3, c, 151, all over 2a. So remember, when we do 2a, go ahead and get that number. 2 times 3 is 6. Now remember, the next thing I'll always ask you to do is take your calculator, plug in what's under the radical exactly as is, and get one number under the radical. Well, guys, the minute that I see that that one number under the radical is negative, that tells me that my answers are going to be imaginary, that square root of a negative turns out an I number. So I see, oh, I've got non-real solutions. Non-real solutions then corresponds to the idea that my parabola doesn't touch the x-axis at all. And now I'm done with this problem. All right, the last one we'll do in this first video segment that just reviews what we were doing before school ended, before spring break, is our fourth example, which is y equals x plus 2 times x minus 10. In this case, my a is 1 because there's nothing that appears before the x plus 2 set of parentheses. And then it's x minus, or x minus a negative 2, x plus 2, and x minus 10. It fits this factored format the best. Now here's the dill pickles. When you go to solving, solving means you've got it set equal to 0. Factored form's the absolute easiest. You don't have to do any work. You just look and answer. So if x plus 2 is a factor, x equals negative 2. If x minus 10 is a factor, x equals positive 10. So these are two real and different solutions. So if you solve and get two real and different solutions, we know that our parabola is going to cross the x-axis twice. So let's take a breather and then start up the next video.